What's up guys, this is Masi, welcome to another video. This video I want to talk about dot product of vectors. Actually, dot product of algebraic vectors. What does that mean? Assume that we have two vectors, vector u, which has these two components, u1 and u2, u1i plus u2j. And on the other hand, we have vector v, which is v1i plus v2j. How do we find out the dot product of algebraic vectors? Using this formula. U dot v, or the dot product of u and v, is going to be u1 v1 plus u2 v2. So find out the dot product. For these examples, we have 4 and 5, and we have 2 and 3. So it's going to be 4 times 2 plus 5 times 3. It will be 8 plus 15, that's going to be 23. The answer to dot product of vector is always a scalar. It's not going to be a vector, it is going to be a scalar as we had it before. Next one, we have 2 and negative 1 and 1 and 2. So it's going to be 2 times 1 plus negative 1 times 2. It's going to be 2 minus 2, that's going to be equal to 0. Next one, we have 0 times 4 plus 3 times negative 2. That will be 0 minus 6. That's going to be negative 6. Next one, we have u dot v. U is 5 and negative 3, and v is 4 and 7, which means that u is 5i minus 3j. v is 4i plus 7j. So when we do u dot v, that's going to be 5 times 4 plus negative 3 times 7. So it's going to be 20 minus 21. That's going to be negative 1. Next one, we have u is negative 2 and 9. V is negative 1 and 0. So again, if I want to write it in this form, it's going to be like that. Negative I plus 0j, which we don't write it. So u dot v will be negative 2 times negative 1 plus 9 times 0. This part is going to be 0. Negative 2 times negative 1 is going to be positive 2. Next one, we have 6 and 1, negative 2 and 3. So u dot v will be 6 times negative 2 plus 1 times 3. That will be negative 12 plus 3, that's going to be negative 9. Next one, we have 5 and 12 and negative 3 and 2. So it's going to be u dot v will be 5 times negative 3 plus 12 times 2. It's going to be negative 15 plus 24. That will be 9. Next one is u is negative 4 and 1 and v is 2 and negative 3. So it's going to be negative 4 times 2 plus 1 times negative. These are all dot products. Negative 4 times 2 is negative 8. 1 times negative 3 is going to be negative 3. That's going to be negative 11. Next one, u dot v is going to be negative 2 times negative 1 plus 5 times negative 2. So it's going to be positive 2 minus 10. That's going to be negative 8. Next one, we have the u dot v, or the dot product of u and v, is going to be 4 times 1 plus negative 2 times negative 1. That will be 4 plus 2, that will be 6. Next one, u dot v will be 3 times 7 plus 4 times negative 2. So it's going to be 21 minus 8, and that's going to make it as 13. Next one, we have 3, 2, negative 2 and 3. So it's 3 times negative 2 plus 2 times negative 3. It's going to be negative 6 and negative 6 is going to be negative 12. Next one, u is 1 and negative 2 and v is negative 2 and 1. So the dot product is going to be 1 times negative 2 plus negative 2 times 1. That will be negative 2 and negative 2. This is going to be negative 4. Sometimes we are dealing with vectors that have 3 components. For example, A is A1i in x direction, A2j in y direction, and A3k in z direction. You have the same thing for B, B1i, B2j, and B3k. So the dot product of A and B is going to be A1b1 plus A2b2 plus A3b3. Still we have a scalar as the answer. So for example, for this one, A is negative 1, 2, and 4, B is 3, 4, 3. So A dot B is negative 1 times 3 plus 2 times 4 plus 4 times 3. So we have negative 3 plus 8 plus 12. That's going to be 20 minus 3, that's 17. Next example, U is 0, 6, 5, V is 2, negative 3, and 1. Compute the following, the dot product of U and V. So it's going to be 0 times 2 plus 6 times negative 3 plus 5 times 1. So it's going to be 0 minus 18 plus 5, that will be negative 13. Next one is dot product of U and U. It's going to be 0 times 0 plus 6 times 6 plus 5 times 5. So it's going to be 0 plus 36 plus 25. That will be 61. Next one, find dot product of U and V. U is 3, negative 4, and 1. V is 5, 2, and negative 6. So that will be 3 times 5 plus negative 4 times 2 plus 1 times negative 6. That will be 15 minus 8 minus 6, which will be 1. Next example, what is the dot product of 1, 2, and 3, 4? That's super simple. 1 times 3 plus 2 times 4. That will be 3 plus 8, and that's going to be 11. Next one, what is 1, 2, 3 dot 4, negative 5, and 6? It's going to be 1 times 4 plus 2 times negative 5 plus 3 times 6. It's going to be 4 minus 10 plus 18. It's going to be 22 minus 10 is going to be 12. Now calculate the dot product of A and B. A is 2i minus 3j plus 5k. B is I plus 2j plus 8k. So A dot B will be 2 times 1 plus negative 3 and 2 plus 5 and 8. So we have 2 minus 6 plus 40. That will be 42 minus 6 is 36. Next one, A dot B will be 4 times 5 plus negative 7 times negative 1 plus 2 times negative 4. So 4 times 5 will be 20. Negative 7 times negative 1 is positive 7. 2 times negative 4 is negative 8. So it's going to be 19. Next one. A is 2 plus 3ij plus 3k. B is 3i minus 2j plus 5k. So A dot B will be 2 times 3 plus 3 times negative 2 plus 3 times 5. So we have 6 minus 6 plus 15. That will be just 15. Next one. A dot B will be 3 times 8 plus 6 times negative 3 plus negative 1 times negative 1. That will be 24 minus 18 plus 1. That will be 7.